Well, thank you very much. I am really happy to be here. It's a cold morning here in Washington, D.C. So I hope that you had a good day. I know it's near the end of the day for folks in India this morning or this evening. So today, and as said, I'm talking about more about these two topics of data literacy and data storytelling. So it's not really focusing on the technology so much as and the mathematics as it's focusing on sort of what sort of aptitudes make a successful data scientist. And so today we'll be talking about this in three categories. I'll be talking about this thing called talking the walk, and that will lead us into the data literacy and data storytelling components of the main lecture today. So talking the walk sort of takes after this quote from a famous man, Albert Einstein. He said, if you can't explain it simply, you don't understand it well enough. Sometimes I've heard people say, he said something like, if you can't explain it to your grandmother, then you don't understand it well enough. And so that's sort of the idea today, is we're trying to explain things in terms that other people can empathize with, can understand, and that includes, for example, if you're working with clients in a business, if you're working with fellow colleagues who may not know the data science as well as you know it, or if you're an instructor or mentoring other people, sometimes they need to start with different level of understanding that maybe you have. So we're not going to be talking about this long list of skills and techniques that a data scientist must have. But if you want to learn more about those kind of things, there's a great report from this group called Figure 8. So Figure 8 did a survey of a lot of data scientists in 2018, last year. And they have a report available that you can read more about what kinds of skills and programming languages and techniques data scientists are using. But that's not what we're here to talk about today. So today we're going to be talking about this being able to explain things. And so I like to say there's sort of three types of data folks. First of all, there's the people who know how to talk the talk. And what that means is that if you sometimes go to conferences and there's a lot of people using the buzzwords, they know how to just talk about it. And everybody's all excited about artificial intelligence and blockchain and Internet of Things and machine learning and data science. And a few years ago, big data. Everyone kept talking about big data all the time. So people who are using all the words in the sentence, but not necessarily understanding everything they were talking about. So that's talking the talk. So that's not very useful. Then there's people who are extremely useful, who are able to do the hard stuff. So that's probably you, or you're doing this already, or you will be this person, being able to walk the talk. That is, you know how to actually do the stuff we're talking about. So that's walking the talk, and that's when you're actually doing the hard stuff for your job, for your business, for your colleagues, for your clients, whoever you're doing that for. But what we're talking about today is this next level, which is being able to take all of that hard stuff and then turn back around and explain it in the common language that other people can understand who are not doing the hard stuff. People who are not trained as data scientists, have not learned about machine learning, don't understand necessarily what artificial intelligence is. And this is really important right now because there's a lot of talk in the world about artificial intelligence. A lot of times people think about movies. And when you see the movies, the artificial intelligence is taking over the world, and maybe it's going to just take our jobs. It's going to destroy life, all kinds of crazy things that make movies interesting and fun. But the real world is a lot more different than that. It's really how we're trying to gain value from our data, trying to gain insights from our data, and try to make that actionable in some way, make things automated in some way. And so, for example, artificial intelligence, I always like to say it's not artificial, it's automated intelligence, or actionable intelligence, or amplified intelligence. So being able to explain it in ways that people understand without being afraid of it. That's talking the walk. And so today we're talking about this, talking the walk. So again, as I said, there's two components, data literacy and data storytelling. So I found this interesting definition of data literacy. And it just basically means these things: the ability to read data, work with data, analyze data, and argue with data. When I say argue, I don't mean have an argument, a disagreement with someone. I mean argue in the logic sense. That is, you're able to make a justifiable recommendation or a decision, like an argument for example, in a logical debate with someone. Like, here's the evidence for why we should do a certain thing. Here's the evidence that shows a certain action is required or a certain insight means something. So being able to use data to communicate, but at the same time starting with the understanding the data, being able to read it, understand it, what does it mean, and then actually work with it and analyze it. So that's a lot of dimensions to data literacy, but nowhere in there does it start talking about specific technologies or algorithms or mathematics. It's just this data as a way of thinking about the world. That is, evidence is what we collect with our eyes and our ears. We collect data and with our sensors, and our bodies have sensors, eyes and ears, and we see and hear things. And so we're always making decisions based upon what we see and hear, and that's the same thing we're trying to do with data science. Collect data and make sense out of it and take action from it. So then data storytelling is really about, again, talking the walk, being able to tell people, what does it mean? And I always say it comes down to these three questions when you talk to someone. The what, so what, and now what? Okay, so what did you do? Why should I care? And what does that mean now? What should, what do I need to do something? Do I need to make a decision, take an action? So what, so what, and now what? And there's a series of quotes on the screen which help remind us of the power of storytelling. For example, at the bottom right there, a famous quote, person says, Maya Angelou, a famous person, said that people will forget what you said, people forget what you did, but they will never forget how you made them feel. So the story is how humans communicate and connect with one another ever since the beginning of time. It's not about technology, it's about human communication. It's about empathizing with other people and just sharing the story and passing down the knowledge. Other more technical definitions about data storytelling is, not in definitions, but ways of thinking about it, is people don't make a decision based upon a number. They need a story. They need so it's the so what and the now what. And so data is a very powerful mechanism for telling stories, because it is, explaining a very human thing, which is we collected some evidence, we saw something, and now we're going to do something. So at the end of the day, it's really about creating value from data. So the value from data is partially achieved when you do the mathematics, when you do the machine learning, when you do the deep analysis, maybe deep learning even. There's some value there, but the value isn't real until it's actually implemented in some way, either in a decision or an action or a business process or a customer interaction or something. And the value is really not so much what did I do, but what did the customer achieve. So your customer can be anybody, and I say customer in a very general sense. I used to work at a university as a professor, and sometimes people would say, well, who's my customer? And I say, well, your customer might be the federal agency that's funding your research. You better make sure your research is aligned with the goals and objectives of the research funding program. Your customer might be other scientists. If they don't read your paper or say positive things and reviews of your paper, then you're not achieving something. So we all have a customer. That customer just might be our boss. It might be a real client that you're paying you money, or it might be just your peers, your colleagues, to accept your work. So what did they want from this? What value are they seeing from this? And so we talk about, it's more about the pull than the push. Okay, don't push your shiny toy, your shiny cool algorithm on somebody, but let them dictate sort of what they want. Listen to them, what do they want, and then deliver something they want. And sometimes that something can be very simple. It doesn't need to be a very complicated deep learning algorithm. So an example of like talking the talk would be saying something like, hey, I've got this deep learning algorithm with convolutional layers. It's got back propagation, and it's using all kinds of and deep convolutions on the network. But if you explain that just this work you're doing in that way to somebody, they may not understand what you're talking about and see any value in it at all. So the talk is not as good as talking the walk. So what does that mean? Oh, I've discovered ways to find hidden patterns in the data that you probably didn't see. And from those patterns, we now see a trend, and this trend suggests that this is an action we should take. And saying something like that, they say, oh, I can see what you're talking about. So let's talk a little bit more about data literacy. So data literacy is being able to understand data and work with data. Okay, so there's this interesting little picture there on the screen. Hope you can see it from a city in California. And you see something that they did here. There's the population of this little town, 562. How many feet above sea level? Okay, so that's about 700 meters, or 2,100 feet above sea level. And then what year was this little town established? So it was established in the year 1951. Okay, so 68 years ago. And so at the bottom, they add these numbers. Well, okay, that's kind of a joke because those are completely different units, different things, right? The first one is number of people. The second one is the elevation above sea level. The third one is a year. So you don't add these numbers. They're completely different things. But a data scientist knows this. But sometimes people who are working with data don't realize that things have different units. Maybe they need to, the units need to be changed. Or maybe they shouldn't be combined at all. Okay, so data literacy, this is a little bit of a joke, of course, but the idea is that we're understanding data. So I like to tell people that data literacy really comes in two components, sort of the yin and yang of data literacy, as knowing how to use data correctly, which is the data science, and then how to use data ethically. Okay, so that's the data ethics piece. And so there's a cartoon here about the boss wants to know, should we use this data? And Dilbert, if you're familiar with Dilbert, he's the data scientist, if you want to think of him that way. And the boss doesn't understand data. So he says, can we use this data? And Dilbert says, no, the data is wrong. Then the boss says, can we use this other data? And then Dilbert says, no, that's also wrong. And then the boss says, well, can you average them? And then Dilbert said, sure, I can multiply them too. Well, that's supposed to be a joke because it doesn't make any sense to multiply or average two databases, but that's someone who doesn't understand data talking with someone who does understand data. And so Dilbert, who does understand data, is just making a silly response to the boss since the boss doesn't understand what he's talking about. So how to use data correctly is being able to understand those proper ways of using data. And then understanding how to use data ethically is illustrated in the bottom cartoon. Again, the same two people talking, the boss who doesn't understand, and then the Dilbert, who's the data scientist in this case. So the boss says, hey, we have all this gigantic database full of customer behavior data, customer behavior information. And then Dilbert, who's the data scientist, is going to do some talking the talk here. He says, hey, we can use some nonlinear math and data mining technology to optimize our retail channels. Well, the boss doesn't really know what Dilbert just said with all those fancy words, so he says, well, gee, if that's the same thing as spam, hey, we're having a good meeting here. So, well, maybe that's not the right thing we should be doing with our data, but anyway, so it's just, again, a cartoon to illustrate sort of the point of the difference between using data correctly, using data ethically, and both of those things are important to the data science. So in any very large data collection, you'll always find some kind of pattern. I like to tell people that if there's a statistical chance, just completely random statistically, for something to occur 1 in a million times, so that's what we call a 6 sigma event. That is, something will occur one time in roughly every million occurrences. That's just a statistically random event. Well, if you have 1 trillion data points, then the chances of you seeing a 1 in a million event is 1 million times. So if you have 1 trillion customer measurements from your hundreds of thousands of customers over hundreds of thousands of days and years and purchases, well, okay, maybe you have hundreds of millions of customers with millions or thousands of purchases, or whatever, or you have data coming across your network your computer network, there's tons of data that comes across networks every day for all the people using networks. So literally trillions of data points. And a rare event, 1 in a million event, will occur 1 million times, and it's just completely random. Okay, so be careful when you find correlations and patterns. They might be random, or they might actually be telling you something, and that's the point of the data scientist, is to exercise that data literacy to analyze those patterns and correlations to see if they're meaningful, to see if there's some truth there, to see if there's some value that can be extracted from those patterns and correlations. Okay, so make sure they're not random and actually meaningful, but at the same time, make sure that they're not just confirming some bias that you have. So you see a pattern that confirms something that you want to believe, but maybe not the most unbiased answer to a question, but the answer that you were looking for, and then you just stop looking at that point because, hey, I found the answer that I'm looking for. So again, we always have to be careful of these biases that get in the way, or misinterpreting random patterns and correlations. So try to find the truth in your data when you explore it. So data fallacies are everywhere. So here's a little cartoon, not so much a cartoon, but these are real fallacies to avoid. And so this company, Kirk Borne, has put together this chart. If you go to their website, you also can download individual, what they call playing cards, individual cards for each one of these fallacies. Of course, the most common one that we hear about all the time is that correlation does not imply causation. So that's a very common one you hear in statistics classes, which we should always be careful of, is not to assume that just because we see a correlation between two things, that they're related to one another, they just happen to occur at the same time or something. So be careful of these different biases. I don't have time to go through all these today, but I should say, you probably saw on the very first slide in the presentation today, there's a link where you can get these slides. And at the end, there's going to be that same link once again. And once you get these slides, you can click on any of the things here. So you can click on the graphic itself, or you can click on the link right there, and it takes you right to the place you need to be to find the stuff on the slide. So one of the ways we think about data literacy is understanding that there's sometimes more structure in the data than we might realize. And I mean, as data scientists, hopefully we've learned this lesson, that when we start combining multiple data sets, you start finding more interesting and richness and patterns in the data that really are meaningful. So not understanding data, we might just, for example, have one parameter. So if you look at this little chart here, if you look at this XY sort of projection of this data cloud, there's two data clouds there, or data clusters, if you want to call them. So there's these two data clusters, and if you look at those two data clusters from the left, that is on the y-axis projection, what you'll see in the y-axis projection is you'll see the basically one distribution, just that one sort of data distribution histogram there. So it looks like there's just a single population of data points there. So if you look at this thing just from that one dimension, you miss the fact that there's actually two clusters. There's two populations in this sample. So if you then collect data from another feature, we'll call X. So if you project along the X-axis and you look at the data from the bottom up, that is along the X dimension, you'll see there's actually two distributions. There's two samples in the population, two different groups, two clusters. And so feature selection and projection is very important to data scientists in order to discover new classes, new behaviors, new events, new things happening in your domain. And so one of the important lessons here is people will often say, well, we have enough data already. Well, maybe you do, but maybe another data set will reveal some new pattern or new segment in the population. So sometimes people will ask me, so, well, how can I get started in my business with data science? How can I get started in my organization with data science? And sometimes I say, just combine two data sets that you've never combined before. Maybe you've been looking at it from one direction, like this bad projection in this plot, this one dimension, and you're missing the fact that there's more information, there's more structure, there's more richness than you realize. So when you combine it with some other data set, let's say looking at it from the bottom direction, all of a sudden you say, wow, there's two different types of customer here. There's two types of events here. We always thought there was just this one type, but now we see there's two types. So sometimes just taking two data sets that you've never combined before and combining them, looking at them from these different directions, data histograms, data distributions, just looking at mins and max and ranges, doing a simple clustering analysis. So k-means clustering. Again, I'm not talking so much about the algorithms today, but k-means clustering has to be like the simplest algorithm in the world. So do some k-means clustering on your data in these two dimensions instead of the one, and say maybe you'll start discovering new structure that can be very valuable to your organization. So feature projection is not only important for class discovery, as we were just talking about, but it's also good for what I call bias busting. Okay, so here's a great illustration, a graphic that somebody put together to illustrate this point. So the little circular cylinder, as we call it, mathematics, the thing in the middle, which is blue on its ends and brown around the circumference of the cylinder, that little circular cylinder, if you look at it from one direction, from the blue direction, it projects to a circle on the screen in the back. And so someone who has only this particular view of their data would say, hey, this thing is a circle. But another person might have a different data set, and they're looking at it from the direction with sort of the orangey brown sort of direction, if you want to think of it that way. They're looking at it from the bottom right, looking towards the other screen, and they say, no, it's not a circle, it's a square. So really, when we project our data into some dimension, some feature space, we are projecting the full truth into a partial truth. And so each one of us, whether we're looking at it from the one direction or the other, we would say, this is the truth, this is true. And we're actually correct. It is true that from that direction it is a circle, and from that direction it is a square. So I'm not talking about circles and squares here. I'm talking about whatever data you're looking at. You might be looking at our customers, you might be looking at events or behaviors, you might be looking at anything. And if you look at it with one data set, you will be missing some aspect of it that maybe someone else is seeing who's looking at it from another dimension. So frequently people get into arguments and say, hey, this is true. And someone will say, no, this is true. And so an argument will happen until someone basically looks at the full, what they call the 360 view, the full view of the thing. And when you do the full view of the thing, you can discover that there's really more structure there. There's more information there than you could have imagined before. And so this is bias busting. It's actually removing that cognitive bias. That is what we only look at it the way we want to look at it, or that we've been trained to look at it. But looking at it in greater dimensions helps to destroy our biases, hopefully, and make us see the full reality of whatever it is we're studying. So think of that high dimensional data, high variety data as a bias buster, but also think of it in terms of data literacy. And that is sometimes if we do get into these disagreements with people about what we see in our data, someone sees this and someone else sees that. And maybe what happens in a case like that is you maybe should take a step back and say, let's go look at some other data that we might have on this sample of customers, this sample of events or behaviors or whatever. Maybe these other data can reveal some structure that we're missing here. So this is important. So another aspect of data literacy is what can you do with the data? So not just sort of how do you what types of data we have, how do we combine them and look at them and examine them and deal with patterns, either random or real, but what are the questions we're trying to answer? And frequently this is where I would start the business conversation. If I'm talking with a business user, maybe a business executive who doesn't know necessarily the language of mathematics and machine learning, which is fine. That's maybe not their business to know that. So start having the conversation this way. Like, what do you want to do? What kind of things are you looking for? New classes, population segments, events, behaviors, customers in your data? Class discovery. Are you trying to find the categories of things in your data? That's class discovery. So for example, that cartoon on the upper left there, so there's 3 major clusters, data cloud 1, 2, and 3. But as we add more data, we start seeing that there's more clusters, there's more categories, groups in the data set. So is that the question? Or is your question correlation discovery, finding the trend line, trend? Okay, so that trend, if you find that X correlates with Y, that's a correlation, and that's a predictive power discovery. So ask the question, are you trying to do predictive modeling, predictive analytics? Are you trying to predict what products will sell? Are you trying to predict whether your customers will like this item? Are you trying to predict whether this particular disease is going to have a bad outcome? Are you trying to predict whether this employee is going to leave the company? Can you predict if this is the best person to hire for the new job you have? So predictive modeling is very important. What is the patterns in the data that are indicative of an outcome? So finding the correlation X versus Y. So we see correlations in that cartoon again. So Data Cloud 3 has a correlation that's slightly increasing from P1 and P2. Data Cloud 2 is much more interesting because there's a correlation in P1 versus P3 that's shallow initially. That is, P3 doesn't change much for those some values of P1. But as P1 becomes more and more negative, you see that P3 becomes more and more positive. So the trend changes. And the trend, the slope, the correlation changes at a particular value of P2. So insight discovery happens when you add that 3rd dimension. And that gives us prescriptive power discovery. So prescriptive means if we want to increase P3 as an outcome, and we know that it varies a certain way with P1, but maybe P1 is something we don't have control over. For example, it might be the seasonal weather, or it might be your customer purchase patterns. Maybe you don't have control over those things, but you do have control over something else. And if P2 is a parameter you have control over, then you get the insight here that if I change P2 in a certain way, then I can change the slope of the response function P3 versus P1. So if we're trying to increase sales, therefore we want to increase P2 because that's going to move the P1, P3 plot to the strong correlation part of that plot upward in P3. If you want to reduce risk or reduce costs in your business, then maybe you'll go to more smaller values of P2, whatever that parameter happens to be. And then we'll start moving down that shallower slope area of P3 becoming smaller as a function of P1. And so insights discovery come from these extra dimensions, especially if those extra dimensions are things that we can manipulate or have control over. For example, the temperature of a machine. You may predict that a machine in a plant, a manufacturing plant, or on an airplane or something might fail. And you don't want that failure to happen. And so if we say we reduce the operating temperature of the machine, then maybe it will continue to work for a very long time. Okay, so it won't fail soon. Okay, so you have control over maybe the temperature in which you operate the machine, or maybe the speed at which you operate the machine. Okay, but you can't turn off the machine because that's your business. You have to produce. Okay, so again, having that control parameter, that treatment parameter, and knowing how your systems respond to it, that's prescriptive power discovery. So again, these are questions we're talking to our customer about. Are you trying to discover these correlations that lead to predictions of prescription? Or number 3 there, maybe you're trying to find the outlier, the anomaly, the surprise, the interesting thing that you didn't expect, the surprising behavior of your customers under certain conditions, or the surprising events in your business line, or in the marketing dimension, or with your employees or something. So finding the anomaly, the outlier, the surprising thing in your data set, the surprising item that people buy on a certain day of the year, a certain holiday, or something that you didn't expect. So finding those surprising things, those outliers and anomalies, surprises in your data. Maybe that's the question. Maybe that's what your business partner is looking for. So again, have these conversations. And then number 4 on this list is slightly different from those. So I have a different little cartoon on the bottom left, which is the association discovery, link discovery. So it's basically network analysis, graph analysis. So finding what's connected to what, okay? Finding the relationships between the things. Okay, graphs are just about entities and their relationships. So customers, and what does this customer want, and maybe that customer will buy something that this other customer purchased because they both like the same products before. Or maybe there's a behavior of something that happens in your machine under certain conditions, and it happens when we see this condition. So those things are related, they're linked, they're connected in some way. Or so we see links and associations in people and events and behaviors, in world news and economic conditions, all kinds of things where we find links and associations. Or maybe it's just a social network analysis, who's connected to whom. If I want to sell this product, if I recommend it to this influencer, maybe that influencer will influence other people to buy my product. So network science is a very powerful tool these days. So is this what your customer or your client is looking for? Are they trying to find associations and interesting links in their data? So these are the kinds of things we can talk about in the context of data. So this is data literacy, again, at a level that a non-mathematical, non-machine learning expert can understand this type of language. And so what we're trying to do is bring our clients, our partners, our colleagues up a higher level of analytics maturity. Instead of just looking at our data as just reporting, that is, create a report of tell me what happened in the past, we're moving up to maybe more diagnostic or real time, like what is happening right now. But even more than that, we want to reach a higher level of maturity of even predicting what will happen. So look at the pattern, the trends in the data, and predict what will happen. So this little map here in the bottom left corner is an example. It's the city of San Francisco. It's a map of the city of San Francisco. And it's a heat map. So highlighted there are the regions of the city where cars have been stolen, so car thefts. And so once they analyze these data, they start recognizing that there was very specific areas of the city where the cars were being stolen. And then they mapped it by day of week and time of day, and they discovered there was a very specific neighborhood and a very specific time and a very specific day when the car thieves were prowling around and finding cars to steal. And so they were able to use this as a predictive model. Before, they just had a list, maybe an Excel spreadsheet listing the car thieves, the days and times, but just a list and an Excel spreadsheet is not very helpful. But you can start doing predictive analytics, just something as simple as just illustrating a data visualization, start revealing their specific place and a specific time and a specific day where this thing will happen. But there's a higher levels of analytics maturity. We've already mentioned one, prescriptive. So prescriptive analytics is that insight discovery, finding what things correlate with something else that leads to an insight that we can take an action that will improve the outcome. So for example, going back to the car theft model there, the predictive analytic, we can say that cars will be stolen in this neighborhood on this day at this time. Well, let's do something about it. So the prescriptive action would be, let's increase maybe the police patrols in that area of the city, more people, more presence of the police will sort of deter the thieves from coming there and taking the cars. And so this deterrence is a form of prescriptive analytics. You sort of prevent something from happening that you don't want to happen. So prescriptive is taking the predictive model and saying, hey, what can we do to achieve a better outcome than the one we're predicting? But really the highest level of analytics, which is where your data literacy skill comes in, your data literacy aptitude comes in, is to realize we're not just at level one here. We're not just answering the questions that people want us to answer. We are finding new questions. Why is this pattern here? Why is this trend here? Why is that hotspot on that time in that part of the city? Well, it turns out the answer to that question is there's actually where the opera or the symphony is playing in San Francisco on Saturday evenings. And so the people would go there and they would go in and watch the symphony or they would watch the opera. And the car thieves would know this, and that's why they would go to that place at that time on that day to find cars to steal. Well, that's very interesting. So, but it started with someone asking the question, why is this pattern here? Why is this trend here? Why is this new behavior? Why is this? So cognitive analytics is asking the right question from your data. It's generating new questions, generating new hypotheses from the data. asking the right question at the right time with this data in the right context. So that's really the highest level of analytics, where you're really doing the cognitive human thing, where you look at something and you say, that's interesting, that's strange, that's funny. Why does that data look like that? So instead of just answering the questions you've been told to answer, which is descriptive analytics, look for new questions. So the difference between predictive and prescriptive, as I said before, is predictive is like saying, given Y, find X. That's, you see a correlation, you tell me Y, I will tell you what X is. So given the data, here's what the outcome will be. That's predictive modeling. So you study the data, you see the patterns and say, given this data, I can predict this outcome. But if you say to yourself, I don't really like that outcome, what can I do to change it? Well, that comes from those insights, those extra dimensions that we talked about, that prescriptive power discovery. So then you say, well, I don't want that outcome Y, I want a different outcome Y. So given the new outcome I want, what conditions can I set to achieve that outcome? So think of predictive as the mathematical statement, given X, find Y, where X is your complete data set. Prescriptive is the mathematical statement, given Y, find X. That is, find the data, find the conditions that I can establish to achieve the outcome that I really want. And so a famous philosopher, Confucius, described predictive analytics this way, even though he didn't know he was talking about predictive analytics 3,000 years ago. But he said, study your past to know your future. So that's basically, look at your training data to know what the outcomes were. And there's this famous funny guy in the United States, we call him the baseball philosopher, Yogi Berra. He said a lot of funny things. One of the things he said is, the future ain't what it used to be. And that's really sort of prescriptive analytics. You predict an outcome, and you don't like that future, you want to change it. You want to make, like for this, you can predict this engine, this is going to fail in your machine, or something like this, or this customer is going to take their business elsewhere, or my employee is going to leave my company. But I don't want that, so I do something to achieve a better outcome. So that's prescriptive analytics. The future ain't what it used to be. So now we're going to go to data storytelling. There's a few minutes left. I have just a few very short stories. These are all short, and then we'll be finishing. And so one of them is just about counting, and then the associations and graphs. And so when we go through these, it's always good to keep in mind that what we're really trying to answer with our story, and this is part of that talking the walk, is what did you do, and to explain that in terms that someone can understand. And so what? Why does it matter? Why do I care? And then the now what? So a simple example comes from some very simple thing called counting. Okay, so here's the world's simplest algorithm, which you learned when you were very, very young in school. Okay, probably when you were 5 years old, or maybe 4 years old, you learned how to count. So counting is an algorithm, right? Because it's just saying how much of something there is. And you think, was this important? Well, yes. So there's a famous case of a business who was managing financial assets. They were managing very large investments for clients. And they discovered analytics a few years ago, and they said, what can we do to do with analytics? And they said, well, maybe we can figure out a way to keep some of our clients from leaving, because every year there's some clients who leave and take their money and invest elsewhere, and we don't want to lose those clients. So what can we do about it? And so they did some investigation, and they looked at their web analytics, very simple web analytics, just counting clicks, if you will, counting how many times the clients visited their account online. And they discovered that the people who took their business elsewhere, they withdrew their investment from this company, and they took the money to some other place, some other investment company probably. They said, look at this. These people who took their money and left us, they actually increased the number of times they visited their account online in the month before they left. So just counting the web clicks, they're able to see a signal in the data and recognize that this was maybe an early warning signal that they were going to take their business elsewhere. And so they reached out to these customers. So there was a predictive model there, right? They predict when they see this signal, they might take their business elsewhere, take their money out of the investment. So they did a prescriptive thing where they did a very simple, what I would call soft response. That is, they sent a very gentle email, not something difficult like, "Hey, what are you doing?" but something simple like, "Hey, did you see we have these new investment calculators? We have a new frequently asked question, FAQ, on our website. Hey, we have these new investment options. Did you see this?" So that by doing this very simple outreach to those customers that had this increased number of clicks on their website, they estimated that they saved, literally a 1,000 return on investment. But that is to say, for the amount of money that they invested to implement this very simple little algorithm, which was about $1 million investment, but they set up the system, and they set up the analytics, and they set up the response, and they set up all this stuff. This investment saved the company in the first 3 months. In the first 3 months, they saved the company $1 billion. So that was a 100,000% return on investment, a 100,000% return on investment, their analytics investment, based simply on counting. So you can tell that story in a way that makes sense to someone. And a business owner said, "Yeah, I can do that. I can learn how to do that. That's just web analytics, that's counting." How about associations? Well, associations are very common. We know all about recommender engines, and it goes even farther back than modern recommenders, because grocery stores or just retail stores discovered years ago that men who go to the store to buy diapers or nappies, however you call them, when they go to the store to buy this, they tend to buy beer at the same time. This was a funny discovery, but businesses use this to recommend products to people now. So we all go to these online stores. People who bought this book also bought this book. People who rented this movie also rented that movie. So we're building recommender engines based upon patterns we see in the data, the associations, the links, the network science. We're doing the network analytics, the graph analytics. So Walmart analyzed their store sales prior to major storms, and in 2004 they noticed in these analysis that customers really wanted to buy one particular product. In fact, it was a 700% increase in the sale of one particular product prior to the arrival of a big hurricane, a big tropical storm or monsoon, you might want to call it. A big hurricane, and they figured out that this is what the customers wanted, and they analyzed thousands, hundreds of thousands of customer sales. And it was not water, it wasn't flashlights, torches, batteries, electrical generators. It wasn't anything like that. The thing that they discovered customers really wanted was this product called strawberry Pop-Tarts. Okay, so it's a breakfast food. And say, wow, everyone was surprised. There's links to articles here where people were shocked that this was what came up from the data analysis. This association between the arrival of a major storm and what product people would buy. There was this amazingly strong correlation, 700% increase. And so you can try to understand this as a data scientist with something like, for example, a composite scoring model, where you basically do a weighted sum of all the attributes of why someone might buy this. Oh, it's a comfort food, it's a snack food, it's a breakfast food. It comes in individually wrapped packages. It has a long shelf life. It doesn't require refrigeration. It doesn't require cooking. So in case I lose power during the storm, or my children want something to comfort them. So if you give points and you score all those different attributes and features of a product, then maybe this one would be the one that people would really want. And then now we can start understanding from a composite scoring model why someone might buy this. But again, look at the data and find the pattern in the data and say, wow, what does that mean? And so Walmart took action. They shipped all strawberry Pop-Tarts they could find to Florida before the next hurricane, and every one of those products sold out. So the prescriptive and predictive model worked. And then the last one is graph analytics. So graph analytics is about finding the associations and links between things. And this is powerful because I would say that the most natural data structure in the world is not Excel spreadsheets. It's not rows and columns. It's a graph. It's all about entities and the relationships between those entities. So whether the entities are people or events or behaviors or products Okay, so the product graph we just talked about, the movie recommender, the book recommender engine, the beer and diaper example, or whatever it is, links and associations, relationships. It's the entities and relationships. It's the graph. That's the most important thing, and it's everywhere. It's in health, it's in telecommunications, it's in security. Just think about networks of people. It's in life sciences, for example, drug discovery and relationship between diseases and diagnoses and treatments. It's all about the graph, the relationships. Same thing in marketing, who's connected to whom. So if this person buys this product, would they recommend it to their friends? So marketing attribution, big use case. So look, location analytics, what things occur at specific places at specific times. Maybe energy shortage or power outage, or some kind of bad storm causing some problem in the electrical power grid or something like this. So all the world is a graph is how I like to say this. And so graphs are really great because the graphs explain customer journey, like how customers move from becoming aware of your product to expressing maybe some desire to buy it, to actually buying it, and then maybe becoming a loyal customer because they come back for more. So being able to tell about your journey, the customer journey, and deciding what kind of products to offer to customers, offer specific customers even, that can be revealed through the graph. So this company, Pointillist, is doing it. This other company, ClickFox, is doing it, using the graph to tell the customer story. And isn't that just perfect? Because a graph looks like a journey. The graph itself even looks like a story being developed right there before your eyes. So data storytelling, it becomes very natural when you do graph modeling and graph analytics, because the graph is, in a sense, a story in visual format. It's the visual movement of something along a trajectory. So think about graph analytics as a new way of analyzing your data if you're not doing that already. Because remember, the natural data structure of data in the world is not rows and columns, but finally, a little recommender here, this interesting book. You can just freely download it from this website. This is great. It's called Data Journalism, about data literacy and about data storytelling. And then the other aspect of that is data visualization. Just like I said, graph models are really good for visualizing data. So it's just a great resource here. There's no cost for it, so I'm just recommending it because I just find it's very, very useful. So the final reminders, and then we'll be finished. We must not only walk the talk, but we must also talk the walk and be able to explain it. And so just two last reminders, and then we're finished. And then one is what this guy said, George Box. He was a famous statistician. He said, all models are wrong, but some are useful. So think about that example where the company was just counting web clicks. Okay, so clearly there's much more reasons why people might want to be leaving that company, might be dissatisfied with something, or unhappy about something, or maybe they're just seeing a better offer somewhere else. But the analytics model worked, just counting how many web clicks, and they were able to retain customers. I mean, again, 100,000% return on investment just from that simple analytic. So yeah, that model might not be the right model to explain customer behavior, but it was useful. So all models are wrong, but some are useful. And then this guy pretty much said similar thing. Everything should be as simple as possible, but no simpler. Okay, so think about those things when you're building your models. So at the end, I'd just like to say, come for the data and stay for the science. That's what I like to think about when I think about data science. There's a link to the slides there, and I think I'm done. So I'd be happy to take some questions, answer some questions. I think there's some already prepared, and I'll be happy to start answering some of those.
Thank you, Dr. Kirk Borne. I think this was a very insightful session. 45 minutes, what we saw, I think it's a mind-changing game. So, sir, first of all, a big thank you from the community for spending your precious time and willing to come down and share your knowledge. So a big thank you on behalf of the community, sir.
You're welcome.
Thank you. So, so we have few questions which the community had posted before the session, and I would like to first go through those questionnaires because these are the ones which we have already collected. Post that, if we do have some extra time, we would like to cover a few of the questions which have come in right now. So let me start with our first question, sir. This question is about the field of data science. Now, in this ever-changing world, data science itself is molding itself in various forms. Things are changing drastically. Everything is like moving. I mean, it's all over the place. I mean, it's very difficult to track the kind of evolvement that data science is undergoing. So, as a leader, what is your observation around data science from an industry as well as from a workforce perspective?
Well, I think first of all, what you just said is our reality, and that is the sort of the half-life, if you will, or the doubling time of technologies and data is unbelievable. I mean, like 1 year or less. It seems like the amount of data we're collecting, I think, doubles every 2 years. But even the new technologies, the new algorithms, and new techniques, it seems like every 2 years there's a complete sort of new development. You know, for example, we saw deep learning started coming well known in the last couple of years, and now we're seeing more reinforcement learning, and also we're seeing the advancement of adversarial networks. Okay, so if you're not familiar with generative adversarial networks, you should really look into this, and especially reinforcement learning. So the trick is just trying to understand sort of what's the latest valuable thing. I mean, there's always new algorithms and new research on algorithms, but there's just too much to keep up with. So I actually personally I like to use my social media account in this regard, because I see what things people are talking about, what blogs are being written, what conferences people are going to, what are the things that people are most talking about it, and those are the things I think to stay focused on, is the ones that are really getting the attention, because you by yourself maybe don't have the time to discover and explore every single new thing, but think of it as crowdsourcing. When you look at on my Twitter profile, I get thousands of notifications every week from people, and I skim through them rapidly. But if I start seeing the same thing multiple times, and I think that's that these people are seeing this as important. So the idea is not to get too far into just reading about all these things, but trying to find the ones that will drive value for your organization. So I go back to the very beginning of my slides where I said one of the most important things we need to be doing is creating value. And so see where the value is being created and go with that, because if it's already been proven elsewhere. But that doesn't mean you stop there. You can do, of course, some exploration on your own, but don't spend all your time exploring algorithms. Let's get something accomplished.
Okay. So as a follow-up question, so suppose data science follows the path which we all expect, like it's going to grow pretty much at a massive pace. How far do you see from the time when humans would be redundant? I mean, in terms of data science, you think humans wouldn't play a big part of the data science process. So how far are we from that stage?
Well, and I hope that never actually happens. I always tell people the two most important things in data science are the data and the science. And that's sort of what that little line means there: come for the data, stay for the science. So the data is the input. So someone asked this question: is the data the driver or the enabler? In some sense, I think the business question, the question, the outcome, the goal, the objective of your organization, whether it's business or research or whatever, that's the driver. The data is the input to answering the questions, achieving the outcomes, and that will never change. But again, it starts with the humans having a conversation about what is it we're trying to accomplish, what are we trying to do, and so the human is at the front end, so to speak. That's driving what data science we try to do. Now there will be technologies which will be the enablers. Okay, so the enablers are the machine learning and the cloud computing and the different things like that. The math, the machine learning, and also the hardware like a cloud. So the technologies are the enablers. The data is the fuel, the input that runs through the technology, if you will, sort of that runs the engine. And at the end, again, we need a human in the loop to interpret, to evaluate, to validate, to make sure there's no bias, to be able to do the what, so what, and now what conversation, because you can just generate all kinds of output models, but if you can't explain it to an executive in a business, an executive in an organization, or a government agency, they're not going to take the risks to just do something just because your model said so. So you need to put the human element, the empathy, the human explanation, the human value proposition. So there will be automation in the technology stack, but you still need the human to monitor and to moderate and to validate all of that. And again, at the very front end and at the very back end, there's that interaction between yourself, the data scientist, and the client, the stakeholder of what you're doing. And so the human will always be there. Definitely some things will be automated, of course. I'm not saying that we won't automate anything. For example, think about a recommender engine on a e-commerce store. There's not a human. It's an algorithm that's generating the recommended. People who bought this book may also like this book. And that's fine. I mean, those things are automated, but again, if the company starts seeing that their recommended engine is not producing revenue, then someone needs to take an action to see what's going on. So the human still needs to be there.
Excellent. So if I understand correctly, so humans are going nowhere. They are going to be a part of the system, and machines cannot replace humans.
They cannot replace science. Let me put it that way.
Science. Okay. Great. The next question would be a little long question. So I'll break it up into, say, 3 parts. And let me ask you, so will deep learning overtake machine learning in the coming days? And if so, what are the researches that you are aware of in deep learning that is actually becoming really popular? Followed by, are you currently involved or are you appreciative of any kind of special projects in the deep learning space?
Well, I would think deep learning is a subset. Well, everyone would say deep learning is a subset of machine learning. So going back to the examples I gave, my 3 examples of the counting, the associations, and the graph models, none of those are deep learning. All of those brought tremendous value to their organizations. Okay, so we will continue to get value from algorithms that are like Einstein would say, as simple as possible, but no simpler. Okay, and even going back to what the other guy, George Box, said, all models are wrong, but some are useful. So even deep learning models are just models. I mean, they're not the reality. They're just a model of the reality. And if you can find a model that works well, maybe your model is much simpler than the deep learning model, but if it gets 70% accuracy and your deep learning model gets 90% accuracy, someone needs to have the conversation. Is that really that important? Well, yes, in some cases it is that important. So deep learning will continue to be, or will grow in use, I think, in things like medical diagnosis, that is computer vision, definitely. Also in natural language processing, where you have massive documents and you're trying to find patterns in data. The new things are these generative networks, where they're generating documents, they're generating outputs. There's a lot of interesting stories there, which I don't have time to get into, some of which go into the data ethics question. So some of the new models are very enriched in terms of not only analyzing data, but outputting data. That's interesting. So deep learning is not going to overtake machine learning. It's just going to be another important part of machine learning, but still we're going to have other models that will continue to be useful, and we should be using even the simpler models when we can.
Awesome. And would you like to share some special project that you are involved or you appreciate?
Well, at my firm, we have every year we've been running this thing called the Data Science Bowl. So datasciencebowl.com. So if you're familiar with the Kaggle competition, so we work with Kaggle as a platform. And for like 4 years, we've run this competition. And so it's data science for social good. And so we put up some data set maybe to solve people to help diagnose lung cancers or heart disease or other types of things, or detection of rare diseases by looking how drugs interact with cells in the body. And so these are very complicated medical research questions dealing with tons of data. And so we've been working with the data science research, the data science community, by these open competitions with very large prizes, cash prizes for the winners of these competitions. And so if you go to datasciencebowl.com, you can read about the four previous years competitions that we have been running, and I was involved with some of those. And so some of them had deep learning as the solution. The computer vision model was the best one to diagnose, for example, the lung cancer or the disease, the effects of different drugs on different diseases in the cells. And so these models were crowdsourced. That is, the community of tens of thousands of data scientists worldwide worked very hard to find the best models to solve these particularly hard problems. And we're very proud of that accomplishment. Basically, it's not us solving it. We're giving the data to the world. We're giving a challenge problem to the world, and we're giving a large prize to incentivize people to try to find the really good solution to this really hard, important problem. The first year we ran it, it was not human health, but ocean health. So you can read about ocean health in Data Science Bowl #1 from 4 years ago. So these are great projects that really taps into the expertise and the passion of data scientists around the world, and I'm very proud to be part of that.
So I think anybody who's in it for the social good, you might want to check out the website datasciencebowl.com. So sir, coming to the next question, there's a question that we get very it's a very popular question back here at Insight, and we get it very often. So a lot of folks who want to kind of enter the space of data science, they come from a certain background. So it could be any background. Say you might be a professional in banking, finance, or you might be a professional in commerce or say arts, or you might have any kind of educational background. Now, they would like to make a switch to data science, partly because they are aware of the field and they see that this is a value add to their knowledge, and partly because they feel that this is the place to be. So what would you guide, what would your guidance be in terms of what is the right role that they should aspire for, and what is the right path that they should be taking from whichever background they come in? How do they fit in back into the data science space?
Well, I always tell people to follow your passion first. Okay, so if your passion is science or art or finance or healthcare or just social good, welfare reform, climate change, whatever your passion is, don't give up what you really love doing. But every dimension of human life and business in the world is now collecting digital data about whatever it is you're doing. Okay, so you just think of like sports, and there's so much digital information in sports, whether it's from video, where people are using video to analyze performance, to analyze practice and training, to analyze results of sporting events. Same thing in art, analyzing maybe on one side of the equation is fraud in art, detecting fraud, but also detecting maybe the original provenance or source of a particular piece of work by analyzing the pattern and say, hey, this looks like the work of this particular artist, but at the same time helping in the design and creation phase. So I'm not saying necessarily if you're an artist, you're going to, it's naturally going to blend together, but it does blend in the sense that an artist is a creative person, and they have that way of seeing the world, that perception that maybe typical scientists like myself wouldn't have that same kind of way of seeing the world and perception of the world and creativity. So data as an enabler, as we said before, as the fuel, as the input. In a sense, it's giving the artist more perspectives and views of the world in ways that can lead to better art or better interpretation and expression. And so no matter where you are, and it's finance and banking is another example. If you're really into finance, if your passion is around finance and things like this, there's a ton of data there. So the data science begins with learning about the data. So this is the data literacy piece. Just work with the data. I always tell people, and I think I mentioned this at the beginning of my talk, If you're looking for a place to start in business with data science, just combine two data sets that you've never combined before. Same thing as an individual. If you're trying to figure out, do I like working with data? I think once you start working with data, if you have a little bit of technical proficiency, you can start doing some simple analyses and combining, looking for trends and correlations, clusters and anomalies and links and associations. But go back to that slide where I said, here are the four types of discovery: class discovery, predictive power, anomaly, novelty discovery, and link association discovery. Start trying some of those things. And I've discovered that a lot of people, once they start doing that, they say, wow, this is fun. You sort of get addicted to it in a sense. You get addicted to discovery. And I think that's perfectly natural, because that's what humans do. Humans love to discover things. We are cognitive beings ever since our beginning. We discover patterns in our world, and we use those patterns as a basis of knowledge to move through the world, to decide how to act and behave and to do things in the world. So that's a very natural thing. So tap into that natural thing that we do, where we analyze evidence and find patterns in it and make actions and decisions based upon the evidence, and incorporate that into the thing that you're passionate about, that whether it's finance or business or sports or science or whatever it happens to be. And so I think it can be a very natural transition. I found that it was pretty natural for me. Of course, my background was science as an astrophysicist, but it was kind of natural to move into conversations with people. Now I talk with people in marketing and cybersecurity and healthcare, electrical power grid. I talk with all kinds of different people about things that I never had any training in at all. But it's all about finding patterns in data, and we can have that conversation.
Awesome. So I think at a very basic level would be start on small steps, take baby steps into this field, and then over a period you might want to attain higher skills.
Start small, but think big.
Think big.
That's what people always say. Think big, start small.
That'll be that's a good insight. So sir, for the follow-up question, so this was about the employee side of the story. How about the company side of the story? So when we think back here in India, especially, I mean, since a lot of our audiences are from India here, so there's a very specific question which actually encompasses a lot of ideas. So back here, a lot of companies are not data enabled, or they're not data proficient. Followed by they also don't know what are the right questions, what are the right problems that they should focus on. So what would your suggestion be for people who are currently working for these companies? How do they get started in data science? How do they convince their companies to start getting data enabled?
Well, the answer will be different for every company, because it depends upon the data that they have. But I think one thing which should be common to almost all of these companies is they should have some kind of online presence. And if you have an online presence, like a website, obviously, or even a social media account, you can start doing web analytics. You can start doing social media analytics. You can basically just start looking at the patterns in the data that's already collected for you in a web analytic tool. I mean, so every e-commerce site, website has web analytics. I mean, I have a very simple little blog site that I publish some of my blogs on. It's called Rocket Data Science. Okay, Rocket, to reflect my background working with the space agency for 20 years. So rocketdatascience.org. Well, it's very trivial, simple little blog site, but there's web analytics that it tells me how frequently people come on and look at stuff, which blogs are getting most people to visit. So you can start finding patterns in your data from something as simple as web analytics. And there's web analytics tools you can buy that helps you to display, visualize. So start thinking about it again from the perspective, not just from the web analytic, which is mostly just reporting. It's a descriptive analytics. So if you go back to my slide where I had the 5 levels of maturity of analytics, think of web analytics as maybe level 1. Okay, it's describing what happened. How many people visited my site? How many people visited this page? And then start analyzing that to see if you see patterns, predictive and prescriptive models, or even cognitive analytics. Well, why is this pattern here? Why is this happening this time of year or this day of the week? or this evening or that morning or this product or that web page. Start thinking about data not as just a reporting function, but as an insight generation function, insight discovery function. So data is not just about reporting, it's about, again, doing the cognitive human thing, discovery, and asking questions when you see something unusual. Why is that? What's going on here? Just an example, so when I was working at the space agency at NASA for many years, we were making data publicly available to the research world. That was our job. We had a research data website where we basically made the NASA data from the astronomy missions available to the research community worldwide. And one day we started analyzing the web analytics once we started collecting the web analytics. This is over 20 years ago, or 20 years ago. And we discovered that there was actually sort of three personas, that is, three categories of users, which of course we probably, of course, knew instinctively that was true, but we actually saw it in the data, in the patterns of the web analytics. So the main user category, persona, was the researcher looking for the research data. And the sort of the pattern of usage of the website illustrated they were going directly to the research data pages. Then we discovered another pattern which reflected another group that we already knew existed, and that's the general public. People who were just coming to the NASA website because NASA has pretty pictures, cool pictures of the universe. I want to go find some pretty pictures of the universe. So people would be navigating all over our website looking for the pretty pictures, and of course we were just mostly providing data, basically data tables, which wasn't very interesting, but we did have some sort of more general pages that people finally found. And so we helped people to navigate to that page by having a link on the front page saying, if you're a researcher, go here. If you're a general public, go there. But we also discovered a third category, and that was sort of in between the two. And it turns out there were people who were looking for the data, the research data, but they weren't researchers. It turns out they were educators, teachers, and students. So these were classroom uses of the data. So teachers were asking their students to work with some data in maybe a science class or a math class. And so they didn't really understand the astronomy per se, but they wanted to do some work with data. And so I would say to people, you can start looking just for patterns like that in your web analytics. Look for clusters and trends and patterns in the usage and the categories of users. These things are not hard to start with. And once you sort of get into that sort of pattern discovery and class discovery and those different types of discoveries we talked about, then again, that sort of inspires more advanced algorithms and more advanced approaches to data science in the business. I always say to people, the best way to build advocacy support for data science in a business and organization is to show proof of value. Prove that through some simple approach, some simple algorithm, or some simple outcome that's producing value for your customers or for your stakeholders, then across the organization, people say, hey, we should do more of this. This is producing value. And so you can build that support through the organization by starting small, but thinking big.
So as a general rule of thumb, is it right to say that maybe you can start with a small problem statement, then step two, build a platform which helps you start collecting information or data around that particular problem statement. And
Exactly.
as and when the platform grows, you try to find the value add that the company is getting from that particular platform. And based on the value add, the company will be more happy to kind of grow the platform further.
Exactly right. I can tell you from my personal experience with that first data story I told about the company who was a financial company, and they were able to increase the retention of these customers that were taking their business elsewhere. So they did the $1 million investment, and after one business quarter, that is after 3 months, they discovered that they had saved the business $1 billion. That was a 100,000% ROI. So after the $1 million investment and the proof of value, which was enormous, I discovered that that company, they told me later, that the board of directors of this company, this was a huge company, by the way, very huge. the board of directors authorized a $300 million investment in a new complete analytics solution group, the platform, the data scientists, everything. And so that very small initial investment triggered such value, produced such value that it triggered this enormous investment. So I agree with you completely. Start with some simple thing, build the value, and that will start building support to add more to the platform. But the thing you said at the very beginning is the most important, is what's the business question? That's why I say the driver is the business question. That's what I say in my slides. I say it's the pull of the customer. What does the customer want? Don't try to push something. Don't come to your boss and say, hey, I want to do some deep learning. Let's see if we can find patterns in our using deep learning. That's too sophisticated or complicated for step one. Step one is to do something that proves value, and then you say we're going to find more value. After people say, yeah, there's value here, what can we do now? And you say, well, you can produce more value with this more sophisticated algorithm, or this more or bigger platform, or more enriched platform. And the good news is that a lot of things are available on the cloud now. There's a lot of cloud service providers that have APIs for machine learning algorithms. So you don't really need to have a platform yourself. You can you can rent a platform. That's what cloud is, right? You can run the API and just pay for the few seconds or few minutes that you use it, and then you're not paying for it anymore. So no longer do you need to buy a big computing infrastructure for your business, unless you're a huge organization, of course. But if you're a small business, you can just use existing infrastructure that's available virtually through cloud service providers. And there's a lot of analytics tools available on those clouds that come with the service. And so there's a lot of stuff you can do without even hiring data scientists or having a huge number of them. I mean, so you need someone who's going to be there to understand this stuff. So again, like you said, think of the business question, start with something that makes sense. It's not going to be too complicated, and try to find the pattern in the data that can produce a better outcome for your business, a desired outcome, an improvement in a process, or a reduction in cost, or reduction in risk, improved sales, whatever it is you're trying to accomplish. And so ask that business question, set that business goal. And I always say not only set the goal, but design in advance a metric. Think about the metric, the performance metric. How can we prove success? How can we prove an improvement? Okay, so what is the metric? What is the numerical quantitative metric that we're going to use to prove proof of value? And make sure you have those things figured out before you start.
Awesome. Sir, I think we have exceeded the time by a lot, but there's the last two questions that I would like to ask you. So the first one would be, this is a very popular question that we get here at NSAID. A lot of people, they are aware of data science, and a lot of people come here to learn data science. They often ask us that during this entire journey, we learn about a lot of academical researches. We learn a lot of topics from the theory perspective. We learn a lot of topics from implementation perspective. But when it goes back to the industry, there is still a gap. So how do we bridge this gap between academics and practice?
Well, that's a hard one. When I first got very interested in machine learning, which was over 20 years ago now, so maybe 21, 22 years ago, I started going to research conferences because that's all there was. There was no such thing as a field of data science or big data analytics. The only place you could go learn about this stuff was to go to academic research conferences on machine learning algorithms and things, data mining algorithms. And at first, I mean, I loved it because I'm a mathematically oriented person, but after a while, I started seeing there was not a lot of real applications. Okay, and I said, this is great, but I already know a lot of math. I'm not here just to learn about math. I want to see what the applications are. I want to see the value that comes from applying these algorithms to all this data that we have. And so finding that balance between the academic and the business is always kind of tricky because some of us will tend to go to one or the other. I mean, again, my background is an academic researcher, so that's where I went. But after a while, I started getting more and more questions from people. How can I apply this to my business? Say, Kirk, you're the expert, Kirk. How can I apply this to my business? And I thought to myself, well, I'm not an expert. I just happen to know something. And so I start realizing that, again, like I said, I can start having conversations with people outside of my business, which was astrophysics. I can start talking to people about all kinds of other things, healthcare and drug discovery and national security and marketing and things like, what do I know about those things? Well, I don't know about those things, but I know about data and pattern discovery data. And so again, it's good to have this sort of some of that background in academics. So I think it's very useful to keep connected with the academic side, because again, that's where the new algorithms are being designed, developed, tested, validated, improved. All of that's very powerful stuff. And again, sort of watch what's emerging in that field. So think about reinforcement learning. So reinforcement learning is basically sort of the way we learn games, so that you can teach machines the same way that we teach, by trial and error. You learn from your mistakes. You have a particular objective or reward, which is what a game is about. You want to win the game. And so reinforcement learning is a lot of attention in that reinforcement learning in the academic research world right now. And that's going to be a really big deal in business. And so it's important to be aware of what the academics are really focusing on, because that's going to be your future in the business. If you have that person on your team, that data scientist who can, translate, again, not just walk the talk, but talk the walk. That is, not only can do the hard stuff, but they can talk about the hard stuff. Again, that's what today's lecture was about. Not only being able to do those hard academic things, but be able to translate it back to a business application, a business need, a business goal. The what, so what, and now what. Being able to talk the walk. So learn the hard stuff, the academic stuff. That's the walk. But bring it back to the stakeholder, to the business, to the client, to the person who doesn't know all that technical academic stuff, and talk that walk with them, so you can now generate value and for yourself and for them. I mean, this increases your value. Let's not forget what we're talking about here. We're talking about you, the data scientist who is being trained to learn this stuff. We're increasing your value by having data literacy and data storytelling aptitudes. It's not just you know these algorithms and you know Python or R or some programming language. It's not just about knowing the programming language and the technical stuff. It's about now communicating and demonstrating value that comes from it. And so that increases your value as well. And so that is what, that for me is sort of how you go from that academic to business side, is you're increasing your knowledge of stuff in the academic side, and then you're translating that knowledge into value for a client in the business side. And since you're that person who's making all that happen, that increases your value.
Yeah, that's pretty nice. So the idea is, if I just rephrase it. So the idea would be pretty straightforward, that academics is going to be that you have to be associated with academics. You get to learn a lot of new things from academics. So once you learn, the constant thought process that you need to develop is, how do I apply what I've learned into my field? So how do I get it into practice and benefit the business? Now, a person who really understands how the education fits back into the business is a person who can actually explain things very simply and is actually appreciated by the stakeholders for the simplicity in the way they translate the academics to actual practice. Right, sir?
Yes. Yes.
Thank you. So one final question is, now this is for a lot of people who kind of are kind of a little different, and there's always two sides of a coin. So this question comes very often. So they ask that, what if I keep myself away from data science? How do you think will my professional life be different?
Oh, you're going to be losing out on the most dynamic thing changing the world right now. No, the world is undergoing digital transformation. I mean, I truly believe everything has some digital component. I mean, so I have in front of me a mobile phone. Every one of us, it seems like, now pretty much it seems like almost everybody has some kind of mobile device. So we're generating data with these things. We're using data with these things. Companies are using our data that we generate from these things. So there's value being created, and why can't we be part of it? And I always tell my students that, who I used to teach a class which was introductory data science, introduction to data science. And these were for students who just needed a science class to graduate from the university. They had no interest in science. They had no interest necessarily in data science. They just needed a science class to graduate from the university. They needed something with math and science in it, and this course provided that. But after they took my class and they said, wow, this is really useful in what I want to do. And some of those students, they had completely different career plans, and they didn't change those career plans. They're still doing what they wanted to do. It's just that they're now recognizing there's a digital signal, there's a digital component, there's data that's in that discipline. And that, again, adds value to you as a employee, as a lifelong career trajectory. Think about the longer term picture, that the more you know about this, the longer your career trajectory will be, and the thing you feel passionate about. I mean, people often wonder to me, said, gee, you were trained as an astrophysicist. I mean, you feel bad that you're not an astrophysicist anymore? And I said, well, yeah, in some sense, because I loved that work. I mean, I don't have time for it now. But what really was inside of me all along was scientific discovery. And that's what I'm doing every day now. So the thing that I felt most passionate about just happened to be in astrophysics, but was discovery. And so you'll realize that you yourself as a human, if we all are, obviously, it's very natural for a human to be excited about discovering new things, because that's how we're wired. We're wired this ever since we were first, came out of the cave, if you will, hundreds of thousands of years ago. We discovered patterns in our world, discovered patterns in nature that enabled us to survive and to navigate through our world. And that's just part of the natural thing of a human being, is to discover patterns and trends and things that we see and hear. And so data is just a surrogate for our eyeballs and our ears. And we're collecting information through these data sensors that are enabling discovery in whatever domain you're working in. So I think you'll find more enrichment, more joy, more. It's actually more human. It's very human to take what you're doing now and to look at the pattern, that's the insight that's coming from a pattern and some data that's related to what you're doing now, and that discovery and taking action on it is very fulfilling. I think there's a great opportunity for having more fulfillment and joy in your work by doing this. I personally believe it.
Well, so I think I have an answer now. So next time somebody asks me, I'll definitely quote you and say that if you are not getting into data science, you're denying yourself the opportunity to discover things, which is what human DNA is all about. So thanks a lot, Dr. Kirk Borne. On behalf of the community, I extend you our gratitude for sparing your precious time to help the community learn a lot, many more things. Before we part our ways, Dr. Borne, I would really want you to give a few suggestions for people who are starting in data science, people who are intermediate, and people who are experts. So what would your recommendation be for the next few years?
Well, be dedicated to learning. One of the things I didn't talk about in my slides here, but one of the other key aptitudes of a successful data scientist is continuous lifelong learning. And I think you don't even need to put data scientists into that sentence. The way to survive in the modern world, where there's so much new stuff, new technologies, new ways of looking at things, new or global understandings, is that to be successful, you have to be a continuous lifelong learner, dedicated to learning. So certainly in the data science world, because there's new knowledge and new algorithms and new techniques and new things all the time, if you're going to be successful in the next few years and not become obsolete a few years from now, dedicate yourself to learning and continue to learn. And so that's how it works. So no matter where you are, in beginning, intermediate, or advanced in this, there are things to be learned, and because there's just so much knowledge out there. And so dedicate yourself to that proposition that you're never completely done learning in life. You're going to be learning till the end. And I mean, I'm dating myself, but I went to college a long time ago. Okay. So 44 years ago, I graduated from college. I mean, that's a very long time ago. Of course, I went to grad school after that, but anyway, 44 years ago. And I'm still, learning every day. I'm learning new things every day. And I don't want to ever get to the place where I feel like I don't need to learn anymore, because that would, in a sense, that's again part of being human. Again, our brains are wired. The neurons, the neural network, which is the biological neural network in our head, unlike the artificial neural network that we call machine learning. The real neural network is constantly wanting to connect things. That's the neurons. And then connections is knowledge, seeing the relationship between things. So give yourself some brain training by learning new things, and no matter where you are in the journey, beginning, middle, or end, or not end, but advanced, dedicate yourself to learning the next new thing or the next thing that makes sense for you.